Hello friends, in this video we are going to look at HashMap. So HashMap is actually not a collection, it's a different one in Java. A map interface is a contract for representing the key value pairs. So that's how people won't call the implementing class as not a collection. So we may see it as a dictionary. The key here maps to an value. We can have duplicate values, but keys should be unique. So the very frequent used methods are put and get. So with the put method, you can add elements to the underlying class. So using the get method, you can retrieve the element which is already added. HashMap is one of the implementing class which we will explore here in this video. That means the HashMap class implements this map interface and offers the functionality. HashMap class. So the Java HashMap class is one of the implementing class of the map interface. The HashMap class implements the map interface. So besides the key value pair, so the HashMap class internally represents these key value pairs. Each key here points to an value. So you can see here in the picture key 1 which is mapped to a value 1. This key value pair together is called an entry. So if you take one entry, key 1 and value 1, they together forms a entity called entry. So you can see HashMap as accumulation of these entries. So HashMap is a collection of entries. Since the HashMap doesn't implement the collection interface, we may not say it as a collection, but the entries that it stores inside can be visualized as a collection of entries. The keySet function returns a set of keys. So this is one view called key view. So by making a call to keySet, you can retrieve only the keys that is stored inside the HashMap. Similarly, one can call the values method to return the values collection. If you look at here, the key is actually a set. So we know about the set. Set means it's a collection, but it maintains uniqueness. So value is actually a collection. So the collection can allow duplicates. So since we can have duplicates in value, the call values won't return a set. It will return a collection. The entrySet function returns key value pairs. Means it returns a set of entries, or we can call it as an entry view. So the HashMap can represent three kind of view. One is the key view, which you are seeing here in the bottom, and other one is the values view, and the third one is the entrySet view. Alright, now let us explore some of the functionality of HashMap in Eclipse. Alright, so here is our first test run. In this test run, we are going to create a map then we will put some elements into this map. After that we will get the elements. So first all we need is the packages. So in Eclipse, when you start adding the functionality, it will automatically import it. But anyhow, here I am just placing it here. Next, in the second snippet, if you see, here we are creating a hash map, and we are creating it as a strongly typed one. And inside the angle bracket, we specified two entities, two data type. The first one is integer and the second one is a string. So what it denotes is, here the first entity denotes a key and second entity denotes a value. That means here we are creating a hash map which will map a string value using the key, which is an integer. So in the left hand side, if you see, we are storing the product map, I mean the hash map, in a reference called the product map. And type, what we are doing is we are stating that as a map interface. So the object we create is a hash map, and the reference type is a map interface. So the type is still same, key integer and value string. Alright. Next, we add key value pair to this product map. So here we already created a product map and stored that in a reference called product map. When we are making call to a sequence of put methods, here we called it 6 times. That means we are storing 6 key value pair inside this product map. So for example, here I'm sending 101 as the key, and value I want to point is a string pen. So here in this case we have integer and string. The data type can be anything. You can even have an object as a key and one more object as a value. So that's also possible. Here our key is integer and the value is actually a string. So the key 101 now maps to the value string pen. So similarly, we added a 6 product. Okay. Next, what we are doing, since we already kept the entry set inside the map, that means key value pair inside the map, now we can retrieve the value by supplying the key. So the method used is get. So for the get method, we will supply the key. Here key is 103. That means what it will retrieve, the get method will retrieve is rubber. For the second one, we are passing 106, so it will return sharpener. Alright. So now we came towards the end of our first run. After placing this code, we will run it once and let us see what happens. So first we create our hash map. So here is our hash map. So when you add an entry, you can see how Eclipse is representing that. So first we added an element, and if you see, it represents that as 101. 101 here is a key, and that maps to a value pen. So if I expand it here, so at 0th location we have 2 entities. One is the key, that is integer. If I click here, you can see that key, and value, which is a pen. That means it's a string. So likewise, we are adding 6 entries. So all 6 entries are added here. So if I click here, you can see how it is represented here. 101 mapping to pen. Similarly 105 mapping to click. So like that you can visualize it. Next, what we are doing, we are giving a key 103. So that means it will retrieve the mapped value, which is rubber. So here it is printed. Product 103 is rubber. Next, we are retrieving 106, and that will show 106 is a sharpener. So that's all in this first test run. Now we will move to the second part. So the replace function of the HashMap. This will replace value in the entry set. So the first parameter what we are passing is the key, and second parameter what we are passing is the modified value. So previously if you see here 102 is pointing to pencil. Now we are making call to replace and we are supplying a new value for it. So the new value is a micro tip pencil. So this function will return the old value. Why? Because the old value here is a pencil. Now we are replacing pencil as a micro tip pencil. So the key is 102. So we are using the key 102 and we are supplying a new value and the function call is the replace. After that, here in the println statement, we are printing product 102 is product map.get. So whatever you saw previously, the same. Now this will return micro tip pencil. Since we already preserved the old value, we are printing that also. Alright, now we will test this. So if you see, the product 102 is changed to micro tip pencil. So we are printing the old value also. So the old value is was a pencil. Now it got changed to micro tip pencil. So that's the use of the replace function. So in this third test run, we are going to check the existence of a key as well as the existence of a value. So in some situation, you may end up in checking whether a particular key exists in the collection. I mean in the map. Similarly, you can check whether a particular value exists in the HashMap. So the function is contains key, which will check whether a particular key exists in the HashMap. So we know that 103 exists and 108 doesn't exist. Similarly, you can check for a specific value also. So the function is a contains value and you can directly pass the value. So this contains key and contains value will tell whether supplied key exists and the supplied value exists. Right, now we will check this. So first we are checking 103. The key 103 exists. So we will, the function contains key will return true here. Next we are checking, this is not 103, so 108. So we have to recompile anyhow. Here if you see 108 it doesn't exist, so this will return false. It should be 108, so I wrongly placed it as 103 previously. Now we are checking whether the value pen available. So pen is there, so it will return true now. Now here we can iterate over the keys. So we can take only the keys from our key value pair, then we can iterate over those keys. If you see, the function is a key set, so it returns an object which implements the set interface. Simply it returns a set of keys. So here is our iterator function. So what we are doing, we are so since it returns key, this should be the function. So we are having a set of keys, then we are taking an iterator. After that we are iterating over that using HashNext and next. So we already saw about iterator and list iterator. So here we are using the same iterator over an integer, because our key is an integer. If you see here, map of integer and string. So that's why here we are representing, when we are writing the function, we are stating set of integer and keys. Then we are iterating over the key, and so HashNext will be helpful to iterate over the key set. The next will give the value. So you can look at our video about iterator to know more about the iterator. So it will iterate over the key set and prints the value in the console output window. So the key set function returns the key set, then we are making call to print keys and we are passing that value returned. So now this will print the list of keys. So first we will add the function. So this is our function. Now we will make a call to that function. So this is our product map, and if we make a call to keyset method of this HashMap, we will get a set of keys. So this is our first view. So it's called a key view. So it extracts only the key from the hash set and returns a key set. So here print key function will iterate over these keys and print the value. And yeah, we don't need to step in, we can directly execute, we can directly make a call to this print keys function and we will see the output. Here if you see, all the keys are printed. So it will be useful when you want to iterate over the keys. Next here, the values. So we already saw in this slide, right? We are just checking that here. The values method on the HashMap returns the collection. So if you see here, this is a set. Why? Because key doesn't allow any duplicate, and we know about the set interface rules. So set interface won't allow duplicate. That's why it is returning a class that implemented the set interface. So we don't know what is the underlying collection, but what we know is based on this return value, whatever object it returns that implements the set interface. Since it returns a set interface, we can call all the set related functionality on the returned object. Alright. Similarly here it returns a collection. It will not return set. Why? Because the values can allow duplicate. So it returns collection. Then we have written a similar function iterator as next and next. So this will iterate over the collection and prints the result. So first we returned the values. So this is a value map. Here if you see, here we can call it as a key view. This is a value view. There are three views, right? Key view, value view, and entry view. So entry view we will look in the next test run. At present we will test this value view. So here we are making call to that new function. So this is our product map. That means a hash map. Here we are making call to the values function. It will return values. And if I click value, we just extracted the value part of our key set. I mean the key value pair. So here is our key value pair. From here we just extracted only the value. So this is our second view. One is the key view, which we already saw. This is the value view. And here we can iterate over that value view and we can print what are all the values our hash map is containing. Alright. Now we will go to our last part. Here if you see, the entry set will return a set, but this set is entry of type integer and string. So an entry is a combination of two entities, right? So one is the key entity, which is integer, and another one is a string entity. That's why you are seeing here a first angle bracket. So the entity is represented as integer and string. So it depends what kind of collection what kind of key value pair you are storing. Here if you see, when we declared it as a hash map of integer and string. That means our key is integer and value is string. So when we make a call to entry set, it is a collection or it is a set of entries. So here is the set of entry, and the entry is of type integer and string. Here also we returned set, but it is just an integer. That's a set of integer, but here it is a set of entry, and entry is a key value mapping. So that's what here, key value pair. And so the entry set returned that, and we stored that in a key value pair reference, and the reference type is a set of entry. Then here in the iterator, the parameter what we are passing here is a set, and the set of type is entry, and entry is a combination of integer and string. The parameter name is key value plus. So here we are returning the map iterator. So now we get iterator to entry of type integer and string. So map iterator is ready. So once map iterator is ready, here we are making call to iterator, right? So whatever it returns an iterator that we store in a map iterator reference. Then we are just printing some header key value. After that, the same usual functionality of iterator as next. After that, we are making call to next. So here if you see, here we already wrote one iterator, right? Here next we will return an integer, because that's the type here. So it's an iterator over an integer, but here it is an iterator over an entry. Since it's an entry, you can make a call to the entry functionality. So entry, first we are getting next, so next will return an entry. That's why we are stating here entry of integer and string. So that's the pair. So for ECDWT you can say it's a pair of integer and string. So that's what called entry. So that we stored in the pair. Then we can make a call to get key and get value to return key integer and value string. Alright, now let me add this function also. So our iterator over the entry is ready. Now we will make a call to that function. So here is our product map. Now we are going to retrieve entry set, and once we make a call to the function entry set, we get key value pass. That means a set of entries. So here is the key value pair. Now we can easily iterate over it. So this time I just stepped into it, and now if you see, 101 is the key, right? That will get printed first. Next we print the value. So the same way we iterate over and we print all the values. So that's all here. So there are three views which we can retrieve from our HashMap. One is the key set. So it will return a set of integer, that means key. So instead of set of integer, I can say set of keys. So the key type here is integer. So that's why we are collecting it as a set of integer. Next, product map dot values. So it will return the value collection. So this one is a key set. You can read like this. Product map key set will return a set of keys or a key set. Then product map dot values. That means the HashMap dot values returns collection of values. So the value type here is a string. So we can say collection of a string. Similarly, the entry set will return the key value pair. Here our key type is integer and value type is a string. So it will return entry set of integer and string. That's all here in this video. Thank you for watching. Bye.